Hello, this problem is lesson 9.10, problem number 11. The directions in this say to use the definition of Taylor series to find the Taylor series centered at the given value c for the function. The function given in this problem is natural log of x. The center that is specified is the center x equals 1. Now, because I'm supposed to do this by definition, I know that I need to find some derivatives. I need to evaluate those derivatives at the center, and then I need to plug it into the structure of a Taylor. So what I've done so far is to take some derivatives. So the derivative of natural log of x is 1 over x. You also could write that as x to the negative 1. And then when I continue to take derivatives, I'm basically just using power rule. I'm avoiding using quotient rule by doing a little bit of rewriting. And so that is, I think, in my opinion, strategically smart. Now, in the next step, what I would do is make a line in my work so I have a separate column, and then this column would be taking each of these functions and evaluating at 1. You might wonder why I did the amount that I did, and I felt confident that I would see a pattern in my work by the time I had 5 terms. But if you think you need to see more, feel free to do more. There's nothing wrong with that. Okay, so the natural log at 1. This is something that you should be aware of from previous math classes, but the natural log function looks like this. And this point is 1 comma 0. So I know that natural log of 1 is 0. There are other ways to think of that, but that is a way. This derivative evaluated at 1 would be 1. The second derivative evaluated at 1, that's a very weird looking one. Sorry about that, guys. All right, so the second derivative evaluated at 1 would be negative 1. The third derivative evaluated at 1 would be 2. And the fourth derivative evaluated at 1 would be negative 6. Okay, so I'm going to take those values now and I'm going to substitute into my Taylor structure. Okay, I'm going to pause to just save you some time. I'll come right back with that. Okay, so this was just substituting in, right? Thinking of my function value for the first term, then the first derivative over the first factorial, x minus 1 to the first, right? So 1, 1, 1. Then the second derivative value over the second factorial, x minus 1 to the second, right? Everything like this, just going through my Taylor structure. And it doesn't really look like very patterny at first glance maybe, but then do a little bit of cleanup. And you see something kind of remarkable. So I didn't rewrite the 0. I didn't write this 1. And I just cleaned this up. So this is a half. This is 2 over 6, which is a third. This is 6 over 24, which is a fourth. And then look at that really nice pattern that emerges. This matches this matches this, that. Oh, should match that. Oops, I missed an exponent there. Yeek. That would have been bad. You all would have had to be emailing me. It would have been a mess. Okay, so that matches that, right? And then here, technically, there's a 1 that matches that invisible 1. So we're doing really well. So we just need to be able to write our sigma notation to express it as a series. So let's do that. So this is one possible answer. So I started my index at 1. So my denominator starts at 1, then goes to 2, then goes to 3. My exponent similarly started at 1 and then went to 2 and then went to 3. I wanted my signs to start out positive, so I made the exponent on the negative 1 work out so that would be the case. Hope this helps.